Hi, today we are going to discuss empirical rule, which is a data for the data with a bell-shaped distribution. Now, this is a concept when interpreting helps in interpreting the value of the standard deviation. And if you recall, and the z-scores, remember you have been calculating the z-scores in chapter 3 using this type of formulas. Z is equal to x minus x bar over s, or z is equal to x minus mu over sigma. So these give you the z-score. So basically what are these? These are values. The z values are going to be on this line, no? Horizontal line, and then we are going to talk about different areas under the curve. So this is a little bit different than how we have used the z-score formula before. We will not use any formula here, like this type of formula, but normal calculations. So here it states these three things. It's also called another name for empirical rule is 68, 95, 99.7% rule. These are percentages actually. 68%, 95%, 99.7% rule. Sometimes it say it like that. So what it says is that about 68% of all values fall within one standard deviation of the mean. So if you have data, so what we are doing basically here is dividing this curve, the bell-shaped curve. So the area under the bell-shaped curve, we take it to be 100% or 1. So we say the area is 1, or we can say it is 100%. So then we divide it into several pieces, kind of. So the middle, because it's symmetric, so if I draw a line in the middle, so it will mean 50% of my data is on the right side and 50% on the left side. So here I have shown that. So now we make further divisions. How do we divide it? So this is going to be the mean value here. Now what we do is go one standard deviation on the right and one standard deviation on the left. Means we go mu plus sigma. So this will be mu plus sigma, and this will be mu minus sigma. So I will subtract the standard deviation from the mean, and it will give me the what I have to put the number under this line. And when I add sigma to the mean, it will give me the number I put under the line on the right side. So now we further go, we go the same distance, whatever this distance is, I go that much over here, draw another line, and same thing on this side. Now this is going to be what we say mu plus 2 sigma. So this is mu plus 2 sigma. We are 2 standard deviation away from the mean, so it means I have to add the one more, like, to this value, or you can say you have to add twice the sigma in the mu. So on this side we will be mu minus 2 sigma. So we subtract once, we get here at the red line on the left of mu, and then if we subtract it twice, we get here. Then third time, now you can see that there is very little stuff left. This will be mu plus 3 sigma, and similarly we go here, so mu minus 3 sigma. So now we will talk about areas under this, between these lines, vertical lines, and under the curve. So the rule is saying that 68% of the data lies in between the first two lines. So here I have so this is mu. This is mu, then this is mu plus sigma, and this will be mu minus sigma. So we say when we are one standard deviation away from the mean, so between that, these two numbers, 68% of our data will lie between these two numbers. So all this data, so this is the middle line, and then one standard deviation from the center, we have the 68% of the data will be in here. So now, for example, a question tells you the mean. So let's say example, mean is, let's say, 50, standard deviation is 10, let's say. So between what range the 68% will lie? We'll say between mu minus sigma, which means 50 minus 10, which is 40, and mu plus sigma, which means 50 plus 10, which is 60. So between 40 and 60, there will be 68% of the data. Sometimes the question is worded like this. What percentage of data or lies, or what percentage of whatever the situation is between, for example, it says between 30 and 70. So you have to check how do you get 30? You get 30 by doing what? By subtracting. Of course, you will have to subtract from the mean because it's less than the mean. So how many standard deviations? 2 standard deviations. Mu minus 2 sigma is going to give you 50 minus 20, which is equal to 30. So you get the first number here. Then you do mu plus 2 sigma, then you get 70. So then you get this number. So you can say, okay, you now know that we are talking about how much data lies with, or how much area of the bell curve lies between two standard deviations away from the mean. So this will be 95%. So this is what I have shown here. So now in these, and similarly between three standard deviations, so this here is for 3 standard deviation. This is mu minus 3 sigma, and this is mu plus 3 sigma. So if you notice mu 1, 2, 3. And so you can see this will be 99.7%. Now this says I'm making it for a general curve. For the standard normal curve, you will not see mu and mu plus sigma. For the standard normal curve, you will see these numbers. So because mean is 0 and standard deviation is 1, so we have 0 in the middle, 1, 2, 3 on the right, and -1, -2, -3 on the left side, these numbers. But in general, in the questions you will get a mean and a sigma, so you can figure out what those numbers are. So now once we know that this, coming back to this first curve, so when we know the middle area is 68%, we can actually see how much is in both halves of this. So we divide 68 by 2 and we get 30%. We get, so this is 34 and 34, right? We divide 68 by 2, we get 34. So 34% in this strip, in this strip from here till here, so that is 34%. And same thing on this side, this will be 34%. So now I also want to see how much is the area, or how much is left, or how much percentage is left. So how do we get that? Well, we know the total is 100%. So if I subtract from the 100%, I subtract this middle portion. So it will be 100 minus 68, which will give me 32. So because of symmetry, we know the area on the left, this area, and area to the right, they are same. So when I am getting 32, it means it's the area of these two added together. So if I divide 32 by 2, I get 16. That's how we know that this is 16% on the left and 16% on the right. So this is the idea. This is how you should be able to figure out any portion of the area that that is in under consideration, or the question, depending on the question you need. So in this case, because we are 2 standard deviations away from the mean, mu minus 2 sigma, and then here we have mu plus 2 sigma. So within 2 standard deviation, 95% of the data lies. So how much is left? So you do 100% minus 95%, or you can do 1 minus 0.95, you get the same thing. If you have 100% minus 95%, you get 5%. And then when you divide 5% by 2, you get 2.5%. So 2.5% on the right and 2.5% on the left. And similarly, the last one. So now we are 3 standard deviations away from the mean. So now this green portion is 99.7%. So how much is left? Okay, again, the same type of calculation there I have done on the side. 100 minus 99.7% is 0.3%. So 0.3 over 2 will be 0.15%. So this tail only 0.15% on each side. So you can see how small it is compared to the whole area. So this we call negligible. Okay, for now, just this much, and then I will do the examples in the next video.